Hi learners, here under differentiation, in the next part we are going to study in detail about the product rule. The formula for product rule is, for example, d by dx of uv is taken as u first function, v second function. Keep the first function as it is without finding the derivative. Now find the derivative of v plus, now you reverse it. Keep the second function as it is without finding the derivative. Now find the derivative of u, that is derivative of uv, that is two functions if it is given, then first function should be taken like that itself, then derivative of second function plus second function, keep it as it is and find the derivative of first function. For example, if you have y is equal to root x into secant x. Now, this is first function, this is second function. Differentiate with respect to x. With respect to x you are differentiating, then dy by dx, or you can take it as y1 or y dash. Place the first function like that itself. Find the derivative of second function, that is secant x is secant x tan x plus second function, keep it as it is. Now root x derivative is 1 by root x, and this will be the answer. Or you can rearrange root x into secant x tan x plus secant x divided by root x. Another example, let y is equal to e power x and log x. Now this is first, e power x is first function, log x is second function. Directly we can go for differentiating. So here differentiate with respect to x. y1 we can take dy by dx, and here in another form y1 is equal to, keep e power x as it is, and now what is derivative of log x? 1 by x plus, now second function take it as it is, and derivative of e power x is e power x itself. Now rearrange y1 equals e power x by x plus log x e power x. Now e power x you can take common. Now rest is 1 by x plus log x. Another example, let us take sin inverse x and log x. Now this is first function, this is second function, y1, or you can take y dash. Y dash is first function, keep it like that only, sin inverse x into derivative of second function is 1 by x plus second function, keep it as it is, sin inverse x derivative is 1 by root of 1 minus x square. Just rearrange sin inverse x by x plus log x by 1 minus x square. That's it. Another example, where y is equal to cosecant x into root x. Now this is first function, this is second function. y1 is equal to, that is derivative. When you differentiate, that is differentiate with respect to x, you are differentiating with respect to x. Here, take the first function like that only. Derivative of root x is 1 by root x plus, now root x, place it like that itself. Derivative of cosecant x is minus cosecant x cot x. Now rearrange. Cosecant x is common. Now the rest is 1 by root x plus into minus minus. Now root x into cosecant x, we have taken it out. The remaining is cot x. This is the answer. And one more final example. Let y is equal to tan 7x into e power ax, e power 3x. Now this is first function, this is second function. Now differentiate with respect to x. Now first function, what you should do, keep it like that only. Tan 7x into e power 3x, the derivative is 3 into e power 3x plus, now second function take as it is, tan 7x, when you take the derivative, you all know that it is 7 secant square 7x, 7 secant square 7x. Now nothing is common here, just rearrange 3 e power 3x. I can take e power 3x common, e power 3x and e power 3x. Now the rest, first take constant, tan 3 tan 7x plus 7 secant square 7x. This will be the answer. So hope this simple video will be helpful for the beginners and also learners to understand how product rule can be used to solve the double functions. Thank you. Hi learners. In differentiation, today I will study about the next part of the formulae, that is trigonometric functions carrying the constant along with the function. For example, derivative of sine x is cos x. But if you take sine ax, it becomes a cos ax. That's very simple. Like that only, like what you have studied in the previous video, you have to study here. D by dx of cos x is equal to minus sine x. Whereas if it is cos ax, you will take a sine ax with the negative sign. D by dx of tan x is secant square x. Similarly, if it is tan ax, its derivative is a secant square ax. D by dx of cot x is minus cosecant square x. we take here ax means and take a here and here also. Similarly, the rest 2 d by dx of secant x is secant x into tan x. When it is secant ax, its derivative is a secant ax tan ax. D by dx of cosecant x is minus cosecant x into cot x. If it is the derivative of cosecant ax, it is a cosecant ax cot ax. With this, we can proceed with other different formulae, taking a value as 2, 3, 4, 5, etc. Now only about 2 we'll study here. Instead of a, I replace it by 2. D by dx of sin ax is a cos ax. Sin 2x is 2 cos 2x. Derivative of cos 2x is minus 2 sin 2x. Just replace all the a by 2. D by dx of tan 2x is 2 secant square 2x. And let's take 3. Derivative of cot 3x is minus 3 cosecant square 3x. D by dx of secant 3x is 3 secant 3x tan 3x. And finally d by dx of cosecant 3x is minus 3 cosecant 3x into cot 3x. Similarly, you can have 4x, 5x, 6x, 7x like that, any values for a. Followed by this is inverse trigonometric functions, derivatives of inverse trigonometric functions. Here d by dx of derivative of sin inverse x is 1 by root of 1 minus x square. When you take the derivative of cos inverse x, it is exactly the same with negative sign, minus 1 by root of 1 minus x square. The same thing what you get for sine, you will get with a negative sign. D by dx of tan inverse x is 1 by 1 plus x square. This implies the derivative of cot inverse x is the same thing with the negative sign, 1 by 1 plus x square. D by dx of secant inverse x is 1 by x root of x square minus 1. Here the derivative of cosecant inverse x is same thing with negative sign, 1 by x root of x square minus 1. X root of x square minus 1. Here, if you check it, you find for sin inverse x 1 by root of 1 minus x square, for tan inverse x 1 by 1 plus x square, For secant inverse x, 1 by x root x square minus 1. Correspondingly, the rest cos inverse, tan, cot inverse and cosecant inverse x derivatives are taken the same values with the negative sign. So this will be made very easy to remember. If you remember sin inverse, tan inverse, secant inverse, it is exactly with the negative sign with respect to cos inverse, cot inverse, cosecant inverse x. X can be replaced by even theta also. And wherever theta is there, you can put x. And this formula will be useful to solve problems not only under differentiation but also in integration. Further, derivative of e power ax is a into e power ax. For example, derivative of e power 5x is 5 into e power 5x. D by dx of, if it is e power minus 7x, I will take negative sign minus 7 e power minus 7x. So we can rewrite this as minus 7 by e power 7x. When you take this to denominator, the power takes the positive sign. The last one, d by dx of log x base 5. I will take this, first I will rewrite this as d by dx of log x base e divided by log 5 base e. I will rewrite log x base 5 as log x base e, log 5 base e. Now I can take d by dx of, first I will take constant outside, 1 by log 5 base e, then d by dx of log x base e. Now 1 by log 5 base e into log x derivative is 1 by x. So we can rewrite this as 1 by x into log 5 base b. Hope this video will be useful for the beginners and also the learners. Thank you.